nucleophilic addition of HCN over carbonyl compounds. HCN is hydrogen cyanide. It is a weak acid. So to make it ionize, we will take a basic medium. So what happens in this step 1? In this step 1, we have HCN that undergoes ionization in the presence of basic medium. Because we are taking basic medium, we will write OH minus. So what will happen is OH minus will take up this H plus. This H plus will be taken by OH minus. So we will get easily Cn minus. So this OH minus attaches to H plus and gives out water. So Cn minus is formed as a nucleophile. That is step 1. Cyanide nucleophile is formed. Now in the next step, step 2, cyanide attacks carbonyl carbon. So we have C double bond O and we have cyanide. So cyanide is attacking this carbonyl group because this pi bond will break towards oxygen because oxygen is more electronegative. So what will happen is oxygen will have a minus charge and this carbon will have a positive charge after bond is broken. One pi bond will break and plus and minus will be there. So cyanide will attach to the positive carbon. So you will get O minus and at the bottom we have cyanide and this is bond free. Now we can have hydrolysis. We can have hydrolysis. What will happen is this H plus will attach to O minus and you get this product OH at the top, cyanide at the bottom, next whatever you can have. Now OH group is present and cyanide is present. So such compounds which have cyanide and OH both are called as cyanohydrin. So this compound is known as cyanohydrin. Alright. So any carbonyl compound, aldehyde, ketone, both can show such reactions. Now question arises, which will show better reaction, whether aldehydes or ketones. So let us discuss this. I have a compound, let's say formaldehyde, HCHO. HCHO is there and we have another compound where ketone is present, acetone. We have taken acetone and formaldehyde. Now if I have to see where nucleophilic addition will be preferred, so you can easily find out from there. Hydrogen size of atoms is smaller. Here methyl groups are present. They are bulky in size, right? Now cyanide has to attach to carbonyl carbon. This has to break like this. Oxygen will get minus, carbon will get plus. Here also minus and plus. Now for cyanide to attack, you can compare. Here the size of atoms is small, so cyanide will easily come and attach to this carbon, whereas in ketones cyanides will have a problem because of this bulky groups. So from this you can easily find out that in aldehydes attack of nucleophile is easy, whereas attack of nucleophile in ketones is difficult. So aldehydes always give better nucleophilic addition as compared to ketones. Alright, and among aldehydes, formaldehyde shows the best nucleophilic addition. So this is what is happening because of size of groups. Next, you can easily figure out that we need more positive charge so that Cn minus can attack any nucleophile for that matter. So more positive is required. So we need electron withdrawing groups, not electron donating. Methyl group applies plus I over here, from here plus I as well. So we have two electron donating groups. So what happens? The positive charge here decreases. So positive charge decreases, so attack of cyanide also decreases. Whereas here hydrogen has no effect, negligible inductive effect. If we have, let's say CCl3 is present over here instead of this, that is electron withdrawing. So any electron withdrawing group will increase nucleophilic addition, right? So both electronic factors and steric hindrance we figure out that aldehydes have a better nucleophilic addition than ketones. So that is what has been shown over here as well. CCl3CHO will have better nucleophilic addition because CCl3 is a electron withdrawing group. So C plus will be more here, then formaldehyde, then acetaldehyde, then other aldehydes, then we have ketones. So ketones are least reactive and aldehydes are more. The smaller the aldehyde, more will be reactivity. Next, we have another reaction with sodium bisulfite. So what happens here is, if I take a carbonyl compound, you have sodium bisulfite. Sodium bisulfite is NaHSO3. So NaHSO3. So how does it ionize? I think you will agree with me that it ionizes Na plus HSO3 minus. Now, what happens? This will break like this, minus and plus, negative attaches to positive carbon and sodium will go to the oxygen atom. So, we get ONA and SO3H, right? From here you can figure out that sulfonic acid is a strong acid. So, what will happen is this will give out H plus. This will give out H plus, SO3 minus and H plus, and what will happen is Na plus will come here. So, you at the end you get a product like this OH, this H plus will go and combine with O minus. This H plus will go and combine with O minus, you will get OH and Na plus comes at the bottom. So, you get sulfonate, sodium sulfonate, right. So, this is the product you will get by the reaction of sodium sulfide. All aldehydes, all ketones, basically methyl ketones will give this reaction, and they here as well aldehydes will always give a better reaction. So that's it. Thank you.